My name is Grace Jansen. I'm a little short, so let me know if you can't see me past cameras or anything. You're welcome to move, and I'll move past the pedestal if you wave at me. But I'm going to stay here for just now so I can move the slides. Hi, welcome. So my name is Grace Jansen. I'm a developer advocate at IBM. If you can probably tell from my accent, not from the USA. I say water with a T and not a D, which kind of gives it away. From the UK, so come all the way over for this conference. It's a great conference. I love coming here. It's about my 5th time here, so it's awesome to be back with the Atlanta dev community. So thanks for joining my session today. I'm going to be covering platform engineering and sort of how we can enable, using platform engineering, how we can help to tackle some of the challenges and the struggles we face as cloud-native developers in this modern era. So why are we excited about moving to the cloud? Why do we put ourselves through this in the first place and face all of these challenges and struggles? And I like to summarize it with this. Hopefully you've seen Toy Story. If you've not, that's your homework for today. Take that away. I think we as developers have this feeling of, ooh, the cloud. Like it gets us excited. We're excited to be building applications for the cloud because it offers portability, flexibility, scalability, innovations that are really hard for us to be able to get if we're not utilizing cloud-native technologies and platforms. But a lot of the time, it doesn't feel like this. It feels more like this. It's frustrating, there's bugs everywhere, it's just plain annoying. And it's going to be really hard sometimes to be able to effectively and easily create cloud-native apps. So hopefully today, we're going to remove those frustrations and go back to happy alien mode of, ooh, the cloud, by utilizing platform engineering and internal developer portals and platforms. So today, this is roughly what we're going to cover. So we're going to take a look at how we even got here in the first place with all of these challenges that we face. Some of those challenges, we're going to take a look at what platform engineering is, what an IDP is, internal developer platform. Note, in this presentation, I am going to be using that acronym for internal developer platform, not internal developer portal. It gets really confusing because when you start looking at literature and blogs, people use it interchangeably. So just note that here it's platform that we're talking about. Portal is separate. We're going to take a look at portal and how it's separate and how it's different. Then we're going to take a look at why do we care about this? Why are we bothering with all this? What benefits does it give us as developers? And then we'll take a look at what tools we can use. And because we're developers, we love a live demo. So I'm going to pray to the demo gods, and hopefully I'll be able to show you a live demo today of one of those tools and how it can help you to create internal developer portals and platforms. Then at the end, I'll have a summary and some resources, so don't worry, there'll be loads of homework at the end, because what do we all want after a conference? More reading and education. So there will be lots at the end for you to take away if you are interested in following this up. Okay, so without further ado, we'll get on to sort of how we got here in the first place and what challenges we're facing. So what happened? Many things, but one of those was this trend of this sort of shift left, this increasing amount of cognitive load that's being placed on developers. You know, nowadays we're having to build it and run it and look at a bunch of other stuff at the same time and hopefully not running away, but hopefully running our application successfully. So, you know, there's this growing trend of these insane words. I don't even know what biz, dev, sec, fin, ML ops even is. But there seems to be an ever-expanding list of responsibilities that we as developers now are responsible for and have to think about in our daily tasks. And what this really translates to is, you know, originally, if we look at traditional app delivery and we take a look at what we were responsible for, we have a happy dev, because the dev knows exactly what he's responsible for. We're looking at applications and maybe some app build as well. You can see in the light blue there. And then the ops are a little bit sad because they have a lot of responsibility here in this traditional method. And you know, it can be quite overwhelming at times. But then if we take a look at modern app delivery, moving to the right-hand side of this slide, you can start to see that the line starts to blur. We start to get more sort of dev ops. Sometimes devs might be doing some more of these sort of traditional ops responsibilities. The devs are quite sad because, you know, they've got more responsibilities now. They're having to think about more. They've got more tasks to do. And the ops are a little bit confused because now there's not really a clear line between what they're supposed to be doing and what the devs are supposed to be doing. So it's all a bit confusing, and there's a lot more cognitive load being placed on developers' shoulders. As well as that, there are too many tools and choices for us to choose from. It's really hard to know which tools are going to be best for our application. I've hopefully made that clear with this picture of what I like to call the cloud-native grocery store. This is where many of us go to figure out which tools we want to use in our own applications. And just to clarify and show you just how hard this can be to actually navigate, I put in a picture of where's Waldo or where's Wally. Can anyone spot him? It's hard, right? Yeah, you got him? Yeah, okay, I've made it a little bit easier by actually pointing him out, okay? Just in case you didn't have time to check it out. But really this highlights the fact that, if you're trying to find one specific tool in this huge landscape, it can be really confusing and hard to determine which tool is going to be best for your application. Another struggle that we face. And unfortunately, it doesn't stop there. There are even more struggles. For example, CI/CD tooling. It is a really steep learning curve to be able to properly and effectively understand not just containers, not just Docker, not just Kubernetes, but everything else that goes beyond and is involved in CI/CD tooling. It takes so much time to learn, and I really enjoyed this diagram because it summarized quite well how I felt. Getting to the point where I thought I'd understood everything. I understood containers, I understood Docker, I understood Kubernetes, and then I realized there's a whole lot more to cloud native than just that. So it is a really steep learning curve, and that's something that we all have to face as we're starting to move towards cloud native. And there are many, many options, as I mentioned, but also, as well as just options of tools to use, there's also many open source standards to choose from as well. So it can be really challenging to know, again, which ones are best for your organization. As well as that, another challenge we face is container management. Being able to have that portability and flexibility that comes from using containers, but having to make a hell of a lot of different decisions when it comes to how do we ensure that we have consistency, how do we ensure we have best practices across our organization when utilizing containers. And there are tools that can help with that, for example, operators and cloud-native build packs, but it is still a really big challenge and another steep learning curve that we face. Another one, which is sort of becoming ever more prevalent, and if you've been to some of the security talks at this conference, I'm sure you got this message drilled into you. Security is important, as we know from things like the Log4Shell events that have happened recently. No clue, Brian, given you've given a talk all on it. So yeah, these are huge sort of, again, tasks and responsibilities that we have to be accountable for in development, understanding what's inside our application through things like SBOM, so software bill of materials, understanding if there's any vulnerabilities in our source code or any of the dependencies we use. Do we have a trusted supply chain? All of these things are things that we as developers now have to be aware of and responsible for. There's also other struggles, like drowning in maintenance costs and scripts, not being able to reach the degree of automation we want to reach, key person dependency, so if we have any maintenance update, we might have to depend on someone. If they're on holiday or they quit, like that becomes a massive issue. Creating an environment can be a really long process, and environments can get blocked by testing. So overall, if you're a little bit dramatic, as I am, it can feel a bit like this. I just don't want to do it anymore. It's really hard. And so hopefully we can fix that. But it's not just me feeling this way. I'm a little dramatic, I have to say. I did go and check out a bunch of different surveys just to confirm that these were all valid concerns that we face in the industry as developers. And as you can see, there's some, so this was by Salesforce. I've got the link down below if you want to check out some of the resource here. This is a study from 2022 where they showed that some of the top causes of developer burnout include things like that increasing workload that I talked about, pressure of digital transformation, having to learn those new skills. So, it's reflected in these industry surveys as well, these challenges, and the fact that they are causing serious issues within sort of efficiency and productivity for development teams. I quite enjoyed Luca's survey here from Twitter. If you total up the no and the slightly ruder no of who wants to actually do ops as part of their responsibilities, you can see it outweighs the people who actually do want to do it. So, how do we actually overcome these struggles? How do we get better productivity and efficiency when we're designing cloud-native applications and hopefully take away some of those challenges and stresses and frustrations that we face as we're building cloud-native applications? And one place we can start to look at is platform engineering, hence why we're in this talk today. Platform engineering is defined in the platformengineering.org website as the discipline of designing and building toolchains and workflows that enable us to be able to be self-sufficient. So essentially, it's about sort of having usually these internal developer platforms which allow us to be able to independently and easily enable us to be able to go through sort of the DevOps processes with best practices, with security compliance, and all that good stuff. A lot of people think that platform engineering is sort of like replacing DevOps. So they think, DevOps is gone, now we have to do platform engineering. But one clarifying thing I want to say here is that actually a lot of platform engineering is underlying in DevOps principles. So DevOps isn't dead. Really, platform engineering is sort of the next evolution of DevOps. You still need the same sort of principles, the same skill sets in platform engineering. It's sort of that next evolution, that next step in DevOps, where it can be seen as that next step or that evolution. So in platform engineering, the way it kind of works is it's like you're making like a recipe book. So the first step you've got to choose when you're sort of implementing platform engineering in your organization is your list of ingredients. Which tools do you need in your organization for each stage of your life cycle? So including things like what IDEs are you going to be using, version control systems, artifacts, observability, Kubernetes, CI tools. You need to be picking the tools for each stage of these life cycles, and that's your list of ingredients, so to say. Once you've got your list of ingredients, you're going to be baking your own platform together. I like to make this analogy to sort of like a recipe book and sort of cooking. So we've got our list of ingredients, and now we're going to bake them all into our platform. So we've chosen the tools at each of these individual stages in our sort of DevOps lifecycle here. And once we bake them in, we're going to bake them into our platform, and then we're going to access them through our portal. Often, the sort of, identification and choosing which ingredients we're going to have and how to bake them in is often the responsibility of a separate platform engineering team. It doesn't have to be, but that's generally the recommendation. And I'll talk more about how those can be created later on in the slides. So this is kind of generally what it looks like when you're enabling platform engineering within your organization. I've mentioned a lot of these terms, and it's kind of useful to be able to define them so we're all on the same page as to what it really means. So what do we mean by an internal developer platform or an IDP? So an IDP, I really like this diagram. This is from, Configure 8? Yeah, which is a provider of, it's sort of got proprietary tools for this. I mentioned some of their stuff later on. But an IDP is really a central collection of tools, services, and automated workflows. So it's basically a collection of those ingredients that we were talking about and recipes. So recipes or workflows for you to be able to easily follow, to be able to very quickly and seamlessly create applications from templates, for example. What it allows is it really allows that self-sufficiency because those workflows and those recipes have already been created for us with those best practices in mind and those security compliance regulations in mind. So it allows us to be able to very easily sort of follow those recipes and already know and not have to worry about what ingredients to use. And to make that even easier, we can utilize internal developer portals. Internal developer portals are different. This is essentially that pane of glass that we can use to be able to access those ingredients and those recipes behind the scenes. So it's this singular interface, which makes it a lot easier for us to be able to interact with the platform behind the scenes. And it allows us, again, to be able to have that self-service ability, to be able to just access one portal and have everything else sort of linked to it behind. So it's important to note, because a lot of people, as I said, get confused, especially when blogs interchangeably use these definitions and these names, especially with the confusion with the acronym, IDP. We in tech love acronyms, it's like Latin half the time. But yeah, it's important to note that these are not the same platform and portals. They are separate, but can be used really well together to be able to enable platform engineering in your own organization. Okay, so why bother with any of this? What is the point of creating more work and more teams for us to get any benefits from it? So some of the benefits we can get for devs is, for example, much better clarity on responsibilities and also hopefully less range of responsibilities and workload specifically on the developer's shoulders. So here you can see we've now got this platform engineering team in the middle that I mentioned before. Many people actually asked, does that platform engineering team have to be new hires, for example? Do you have to go out and find people who are platform engineers? And the answer isn't necessarily yes or no. It really depends on your organization. If you want to go out and find people who are experienced in platform engineering, absolutely, feel free. If you've got the hiring, great. But it doesn't have to be. What it could be is experienced devs or ops who understand your application already, but want to do sort of more in the space of choosing those ingredients, making those recipe books, deciding on those workflows. So it can just be experienced developers and ops who choose to go into the platform engineering team. It doesn't have to be new hires. These skills can be sort of learned and developed. And really what we're doing here is separating it out. So now the platform engineering team are in charge of choosing those ingredients and creating those recipes or those workflows. Developers can just focus on making fantastically great, innovative applications, as we love to do, and ops have much better clarity on exactly what they're responsible for here. Now, I know, actually, who in the room here is actually a developer? I should ask that first. Yeah, most of the hands in the room. Cool, that's what I expected. So, as developers, we don't always necessarily look at the quantitative benefits, because often it's qualitative benefits that impact us the most. But at the end of the day, it's often decision makers who need quantitative benefits to be able to enable these changes to take place. So I added this slide in case anyone needs to persuade anyone in their company that this might be worthwhile. You can see some of the actual measurable impacts that introducing platform engineering can actually have. This is a study done by Humanitech, and you can see here that wait times due to blocked environments decreased, average deployment frequency was able to go up, visibility and transparency across teams improved, onboarding improved, and lead time decreased. So you can see some real measurable impacts that can lead to value in terms of cost savings or in terms of better productivity, for example, that can really have an actual physical and measurable impact on your company. Now, I added this slide in because I don't want people to sort of come to this session and think, platform engineering, it's a must. Everyone has to do it. It's a bit like, when microservices was first introduced and everyone thought everyone should always do microservices. There are good and bad to every new technology, tool, or methodology. So it's worth considering whether this is right for you and your company based on sort of the benefits that you can gain, like I discussed, but also some of the challenges that come with that, and whether you can sort of deal with those challenges and whether the benefits outweigh them. So some of the benefits that I mentioned: increased developer autonomy with that self-service model, reduced time to market as well, as I showed with some of that quantitative data, and then also improved developer satisfaction as well. But some of the challenges that come with that is, when you're introducing platform engineering and you're having to develop an internal developer portal or an internal developer platform, if you have a really small platform engineering team serving a huge number of developers, that's a huge strain on those few people in the platform engineering team. So you have to make sure that it's scalable. You have to put enough resources into that platform engineering team to actually make this viable. So that's another thing to sort of consider, as well as obviously challenges around being able to provide a solution that is able to be used by every team. There are always going to be edge cases. There are always going to be tools that some teams need and other teams don't. So again, it also depends on your team structure and your application needs for each of those individual teams. So just bear that in mind when you're considering whether platform engineering is for you. So hopefully what I've shown so far is that platform engineering is kind of cool. IDPs could be interesting, and that there are some benefits that you can gain from it. So how do we actually go about using this and implementing it in our own organizations? What tools can we use? So there is no real single open source tool. There's not one single magic button you can use, unfortunately, but there are lots of open source tools that you can check out that are helpful. So starting at the very sort of highest level, we have sort of reference architectures that you can check out. So I've got a couple of examples here, one from Humanitech and one from McKinsey. So these are sort of reference architectures that really show how you could divide out the different parts into sort of subgroups. So we've got things like the developer control plane, integration and delivery, monitoring and logging. And these give an idea of sort of where you might have to make those decisions on the ingredients that you might need within your internal developer platform. There's also the IDP tooling landscape from platformengineering.org. It's a fantastic resource, so check out the website. It's open source and sort of community driven. And this sort of lists out all of the different, or many of the different tools that you can use for those different planes that we were looking at in that reference architecture. And sort of, again, some of those same subgroupings and what pluggable tools can be used together. So that's kind of at the platform level, so how to choose those ingredients and create those recipe books and what you need to consider for each of those stages. But there's also portals as well, as I mentioned, platforms and portals hand in hand. So when it comes to portals, there are several open source tools you can check out. Backstage is probably one of the most well-known and one of the most popular. So it was originally donated by Spotify, and it is a CNCF incubating project, getting really popular at the moment. And it essentially offers, out the box, a software catalog for managing all your software templates, which we'll go on to in a minute, and as well as that tech doc. The nice thing is it's got this sort of centralized software catalog, it's customizable with plugins, and the plugin landscape is really growing at a really fast rate for this. So many companies are starting to develop plugins for Backstage to allow you to be able to more easily utilize their tools if you select their tool as the ingredient in your platform. So there's a website, backstage.io, you can check out if you are interested. As an alternative, you can also check out Red Hat Developer Hub. So this was originally sort of a downstream of Backstage. However, there are some differences between the two. One of the biggest differences is that Backstage has static plugins. So what that means is that you really need JavaScript experience to be able to actually go about utilizing and sort of playing around with those, and if you want to make your own, for example. Red Hat Developer Hub sort of abstracted that a layer up to allow you to be able to do all that with YAML files using dynamic plugins. So it's a much easier interface, and it's also enterprise ready. Now, Backstage kind of realized that dynamic plugins actually are pretty useful. So they are implementing that currently back into the upstream. So that is coming, which is why Jansen, which is the project that kind of came as the in-between between Red Hat Developer Hub and Backstage, that was created because of those differences. That's now been deprecated, and eventually, once those changes have been implemented in Backstage, it will be a direct upstream once again. But it essentially adds on sort of enterprise support and has an opinionated framework sort of skewed towards use in OpenShift, for example, as it already has plugins and software templates available for that sort of suite of products. But it is a really great tool, and this is the one we're going to utilize in our demo today to hopefully showcase how you can utilize this to create your own. Okay, praying to the demo gods. All right, so I have here an instance. Now, I should check on font size. How's the font size at the back? Is it okay? Bigger? It's okay? Yeah? Yeah? Cool. Okay. If it's big, if it needs to be bigger, just shout. That's fine, or raise your hand. So this is an instance of Red Hat Developer Hub, which is that sort of more enterprise-ready version of Backstage on an OpenShift cluster. So for this, I'm going to be looking at sort of how do we create those recipes that I was talking about once we've chosen the ingredients in this portal. So let's say we've already gone through the process of selecting what ingredients we want, and we've started to make those recipes, and we now want to install them into our portal to make it much easier for our developers to go about creating these applications. So to do that, we're going to start registering software templates. So software templates are essentially those recipes to allow us to be able to set out those workflows and sort of have those opinionated ingredients that we want to include to be able to make it much easier for them to just go through sort of a really rough form to be able to actually go through and like populate it with data to be able to create those applications. So I've already made a software template. In this case, it is for OpenLiberty. Actually, I should show the, if I go right back to the beginning. Oh, actually, it's going to be on here. I have a recording, just in case this doesn't work. You can never be too cautious, so I've got to back up. So in this case, this is kind of the architecture of the demo here. So we've got Tekton, Jenkins, and GitLab being used for our CI part. We've got Quay being used, or Key, I never know how you pronounce it, I think it's Quay. Quay being used for the images and sort of our image registry. We are also utilizing OpenShift to be able to sort of run all of this. So the nice thing about this is that it's kind of, you can utilize it on any cloud, and it's very flexible and portable that way. So going back to this, as I said, I've already created a software template. To be able to register these recipes or software templates, you can just go to the Create tab here and go to Register Existing Component. You'll need the URL of essentially our template YAML. So if I show you our GitHub repository, so you can check this out on GitHub. It's all open source if you are interested in checking out this example. Here, we are actually utilizing OpenLiberty. Has anyone come across OpenLiberty as a runtime before? No? Any hands? Couple hands. Yeah? Ish? Kind of? Unsure. Okay. So if anyone's unsure, OpenLiberty is a cloud-native runtime. So it was originally developed by IBM as Liberty, and then it was open-sourced entirely in 2017 to be OpenLiberty. So it's a really lightweight and modular cloud-native runtime, and it implements and makes use of open-source standards and community-driven projects like Jakarta EE and MicroProfile. It's super performant, lightweight, very fast startup time, and sort of really great focus on developers using it. So definitely check out openliberty.io if you haven't seen it before, or check us out on social. I run the social media, so I'll say hi if you come follow us. Okay, so that's what we're using as one of the ingredients in this recipe, which is, again, online if you want to check it out. So in this case, we're pointing it inside our artifacts to our software templates, and in this case, we're pointing it to the Liberty template as the one we want to install. So this template is essentially sort of, as I said, that it allows us to create that workflow. It's made up of parameters. So these parameters are going to be populated by the form that's going to appear in the portal as a result of importing this software template. So we can add all of those as part of the form. And then at the bottom, it's also got some steps here. And the steps are essentially things that need to be done at that initiation time for our software template. So I can just add in the URL for that into my Red Hat Developer Hub. I can analyze it. I already have it installed because I did it just before, just to check this was working. So we're just going to refresh to see if there's any changes, which there doesn't seem to be. So now if I go back to Create, you can see it here in the OpenLiberty Starter app. So this is just, it creates a very simple OpenLiberty application that utilizes MicroProfile. Now in this case, this environment does not have GitHub enabled. So I can go through the CI pipeline, but it's going to fail, and I know it's going to fail, because we have GitLab enabled in this, not GitHub. So I'd need to change my software template to GitLab if I wanted to make use of it in this OpenShift cluster. But you can essentially go through the instructions. So let's say team 1 is my repo owner. You can start to see that it's basically asking me to populate those parameters that were inside my template.yaml file. It's a super easy and simple form, which makes it really easy for any new developers coming in to onboard to utilizing this to create a brand new application. In the meantime, I'm going to go and show you one that does use GitLab. So this is the wind turbine game. So in this, you can see we've already pre-populated a lot of the fields. We're choosing things like a name, description, what cluster ID we want, image registry. So in this case, we're going to use Quay. And again, we populate it with things like the organization, tags, for example, host ID, where we want it to be stored for repos. So in this case, we want it stored inside our GitLab. And in this case, again, in the interest of time, I went ahead and already bootstrapped this application so that I can show it to you guys in Red Hat Developer Hub. So you can see when I install this game software template and I enable it and I sort of bootstrap it, what it gives me is 2 repositories. So I've got the game secure and the game secure GitOps. The reason for this is that we made a choice that we wanted to separate out the sort of CD part of it from the rest of the source code. That's a personal choice. You don't have to create 2 repos if you don't want to. That's completely up to you. This is where those choices are made by the platform engineering teams as to what those workflows are going to look like when it comes to creating those software templates. So I can click into this and check out sort of what's inside my source code. But essentially, if I go to my Red Hat Developer Hub, yeah, I'm just double checking I've got this in the right order. Cool, yeah. So if I go into my catalog, you can see that I've got the component in here for my game secure. And we can click into that and see sort of the details on that and what's going on. The nice thing about having a portal like this is that you can dive deeper into the components that are created by those software templates and you can see it all in one view. So I can see the overview here, which is sort of a summary of all the tabs above, but I can see things like the CI pipeline, so I can see that it succeeded, there we go, 9 minutes and 39 seconds ago, and I can deep dive into that as well, and we'll do that in a minute when I restart it. But I can also see things like topology. So I can check out things like, is my development environment running correctly? Is my production environment or staging environment running, and why aren't they? So this is kind of the Kubernetes view of whether they're up and running and healthy or not. And you can deep dive into that as well. So the nice thing about having this all pre-populated and set up is that once I make a change to something in my repository, it will automatically kick off that CI/CD pipeline again to sort of synchronize with any of those changes that have been made. So if I go into my application, I've gone into the wrong bit, I think. SLC, let me check that I'm in the right area. Oh, I've lost it now. There it is, game secure, SLC, main web UI. Oh, there it is, yeah. I was one too far above. Okay, so if I now edit this, now, okay, I'm doing this directly in GitLab. I wouldn't necessarily recommend the way I'm doing this right now, but for the sake of a demo, we can all forgive taking a few shortcuts just for the sake of this, so don't follow what I do for this particular one. So I'm gonna edit a single file. So in this case, this is a racing game, and I'm just editing the web UI just to show a very simple change, just so we can kick off this sort of build. So I'm just gonna change the number of taps required per user from 200 to 250 in this case. Again, not best practice, but I'm just gonna go and commit those changes. So forgive me for that. So now that I've done that, I can go back to my topology view and go back to sort of the overview. What it should have done now is, there we go, it's kicked off automatically, just from me committing that change, it's automatically kicked off that CI/CD pipeline. So I don't have to worry about going into sort of, I call it bookmark hell, of like, you've got so many tools and you don't necessarily easily know where they all are, and you have to bookmark all of them to the point where you've got a huge list of bookmarks that you have to know exactly where each tool is. Instead of that, you now have one single pane of glass to be able to see all of that in one go. So you can see that we've got the sort of CI pipeline going right now. So in here, once the git clone goes through, we essentially package it up. We do some sort of scanning and signing the image because containers can be tampered with. So we want to make sure that we're utilizing the right image. And so by signing it, we can be sure that it is the correct image that we want to be using. We do things like SBOM analysis. So do we know what's in our application? That's software bill of materials. And then we also do things like ACS, which is sort of more security checks at that point. And then eventually what we'll do is this resync, to be able to resync and send it to Argo CD to say, look, this is the source code we want to be building, these are the images, and go ahead and get that built. If I go to the CD tab, you can see that at the moment it's degraded because we don't have anything built right now. But this tab is really useful to be able to know sort of what state we're in, and why something might not be synced yet, and the reason for that from Argo. Other things you can see within Red Hat Developer Hub, within this pane of glass, is things like image registry, for example. We can start to see the images that we're making use of here. We can also see things like issues. I really like this one because, I don't know about you, but sometimes you can like open an issue, or even things like pull and merge requests. You can open a pull request and nobody looks at it for days because they're too busy with everything else. So the nice thing about this is by having it all in one interface, whilst you're waiting for your CI/CD pipeline to finish, in the same view, you can also see some of the pull requests and the merge requests that are sort of haven't been completed yet, and you can go and check those out to sort of fill that time, which is quite nice to see it all in one view. You can also see things like API definitions. So these are just the APIs that are relevant for this particular application. But you can also see in the catalog here, in this tab APIs, a list of all the APIs that you have access to within sort of your entire organization. Again, that depends on authorization of who you give permission to be able to see those APIs. But the nice thing about this is that if we deep dive into it, you can actually see the dependencies for the particular API, for example. And you can see sort of in this graph view, if we increase that, you can start to see how these all link together. So you can start to see organizations or sub-organizations like the Red Hat Developer Hub group here. You can see that maybe I've got a team 1 that's a subgroup of that, and you can see all the APIs that they might be making use of or responsible for, and the dependencies that that has. So it can make a really useful sort of tool to be able to navigate your organization. And you can also, for example, deep dive into sort of the APIs as well to see their sort of Swagger definition as well, to be able to understand more about how to utilize that API as you would with Swagger documentation anyway. But the nice thing is it's all, again, in one view and one pane, so you don't actually have to leave that application at all to be able to see all of this. So, as well as that, there's also, if I go back to my catalog, back in here, there's also the ability to be able to add in documentation straight into this interface as well. In this case, we've just ported in the README for this particular game. And if you were in any of Kevin's sessions, you might have seen this game. Thanks, Kevin. So in this case, we've imported the README. Now, that's not to say you have to import the README into the documentation section. The nice thing about this is everything is customizable. So it's really up to you as to what you include. It could be a list of links to documentation elsewhere where you maintain and keep it. The nice thing is it's really up to you as to what you populate this with and how you utilize it. Okay, so in the interest of time, because I know we don't have that much longer left, I'm going to go back to the slides. But actually, let me see how this is doing. It's still running. We'll check it later. We'll come back to that. This is why I did it first time, to save that time. Okay, so I like to try and also make sure that I'm not just saying, this is the only option out there. There are other options. So if any of these tools you already have licenses to or they suit you better, there's lots of options out there. Like, for example, Kratix is another one. That utilizes contracts to be able to create the internal developer platforms. Again, Kubernetes-based. And there's other proprietary products as well. If you head to, it's kind of covered here, sorry, but internaldeveloperplatform.org/developer portals, there's a whole list there of different tools that you can make use of if you don't fancy using any of the ones I've shown so far. I will share these slides, so if anyone doesn't get, I saw pictures almost there, sorry, I move on too fast. Thumbs up. I will share it. I've got loads of links, so you can follow it all afterwards, I promise. Okay, so hopefully we've gone away from the whole let's build it, let's run away, and now we can utilize IDPs to really guide us forward and make this a much easier journey as we start to develop effective cloud-native applications. So, in summary, hopefully, as I've said, I've shown so far that cognitive load and demands on developers means that we have an ever-increasing amount of sort of responsibility and struggles as we try and move towards cloud-native development. But the nice thing is, we're not alone. We can utilize things like platform engineering, internal developer platforms, internal developer portals, together, hand in hand, they are different, and those golden or paved paths. That's another word that we like to use to describe those recipes or software templates that we make use of. But what this looks like will be very specific to your organization, because your list of ingredients is going to be very different to someone else's list of ingredients. And your recipes and workflows are, again, going to be very different to, say, someone else's. You can also have, for example, multiple different recipes, depending on what your teams might need. So I showed one for OpenLiberty there, and another one with the game server. It really depends on what your organization's needs are as to how many workflows or recipes you create and what those look like. But we can utilize the tools and technologies and examples that are already out there to help us with these choices. So, homework, because everyone loves homework. Okay, I've got some resources here that are hopefully useful. So I know it can be really daunting coming into this and sort of learning platform engineering for the first time and thinking, how can it apply to my organization? So I've added here a list of examples of organizations that are of differing sizes. So hopefully one of these will be relatable to you in your own organization. And you can check out their sort of success stories of implementing platform engineering in their own organizations and what benefits that brought to them. So, ranging from the huge Netflix down to sort of smaller organizations as well. As well as that, there's also a huge community out there that you can rely on and look for help from as well. So the platform engineering community is fantastic. They have a weekly newsletter you can subscribe to. They also have a conference that occurs every year. And the nice thing is they put all their sessions up on YouTube, so you can check them out if you want to. And they're only 20 minutes long, so quite consumable, easy to watch. There's also the platform engineering guide available from InfoQ that you can also check out, and the Slack channel you can join if you don't have enough Slack channels already. I know I do. There's also additional resources here. So some of these are blogs that I created, and my partner, Martin, who I've been working with, he's a Red Hatter. We've been creating these workshops, like the GitHub repo, the software template, and documentation on how to make use of Red Hat Developer Hub. We've written some blogs on it, so do check those out if you are interested. And some of these sort of help to summarize some of the information I've been sort of presenting in this session today. If you're interested in getting hands-on, because we love getting hands-on as developers, you can try a lot of this for yourself for free. As I said, the GitHub that I showed is an open source repository. We actually created it as a workshop, so you can follow all the steps in that README, utilizing the free sandbox environment from Red Hat to be able to utilize Red Hat Developer Hub and try it for free. So you can check that out. It is available for free on GitHub, and follow the steps. If anyone has issues with any of that, please let us know, raise an issue. We're always looking to improve it, so we're actively working on that at the moment. But there's also other ways of doing it, so going directly to the developers' sandbox as well, or checking out OpenLiberty, like I mentioned. We have a fantastic website with some really great tutorials and guides that are interactive and free to use. If you want to learn about microprofile or Jakarta EE, definitely go check those out. If you want to learn more, I would say come and visit the IBM booth, but it's so late in the day, I feel like it's going to be taken down by the time we get out. So don't come visit the booth, but do join our Java community. There is a QR code there if you'd like to learn more about OpenLiberty or any of the stuff we've been getting involved in around this space. And we have a survey. Doesn't everyone love a survey? We'd love to learn more about where you're at in your development and modernization lifecycle. So if you have 5 minutes spare, and you fancy helping us out, we would really appreciate it. And if you want to keep in touch, do use the link here, and yeah, we'll let you know. With that, I'm going to say thank you very much. I know I'm slightly early, but again, I didn't want to hold people for the quiz and the raffle after this. So thank you for that. Hopefully, this has been a helpful introduction to platform engineering. As I said, I will be sharing the slides, so do feel free to follow me on Twitter or on LinkedIn. I'll probably be posting the links on both of those sites, and I'll send it to Devnexus as well, just so they have a copy. And if you have any questions, I'd be happy to answer them. Otherwise, it's late in the day. Feel free to message me on social media at any time in the next few weeks when you're trying it out yourself. Thank you very much for your time.